Welcome to Programming Fluency. This is section 6.3, Pointers and Arrays. You have already used pointers and you have already used arrays. In this video, we connect them. It turns out arrays and pointers are deeply related in C, and one simple rule explains three mysteries you have already met. Let's begin. Arrays and pointers are deeply related in C. One simple rule explains three mysteries you have already met. That rule is called array decay. Let's see it. This is the plan for this video. We begin with array decay. In most expressions, an array name quietly turns into a pointer to its first element. This one idea explains the puzzles you have already met. Next, we see when decay does and does not happen. The sizeof operator and the address-of operator both keep the whole array, so they are the two exceptions to the rule. Then we look at the key equivalents. Writing r of I is exactly the same as star. R plus I, you will see 5 different ways to write the very same array access. After that, we pass arrays to functions. Decay explains why the length information is lost at the boundary and why a function can still change the caller's array. Finally, we are clear that arrays are not pointers. We look at the real differences between them, including why you cannot assign to an array name. Let's start with 3 puzzles you have already met. First, you wrote int star p equals r, and it made a pointer to the first element with no ampersand needed. Second, you passed an array to a function, and the function changed the original data, even though C passes everything by value. Third, sizeof r divided by sizeof r of 0 counts the elements, but it breaks inside a function. All 3 puzzles have the same answer. That answer is called array decay. So what is array decay? When you use an array name in most expressions, C automatically converts it to a pointer to its first element. In most expression contexts, an array name becomes the same as ampersand r of 0. This conversion throws away the size information. The array is not copied, the size is lost, only the starting address is left. Let's see decay in action. We make an array of 5 ints. Then we write int star p equals r. The name r decays to ampersand r of 0, the address of the first element. The output shows p and r and ampersand r of 0 all print the same address. That is why int star p equals r works with no ampersand. The array name already decayed into the address you needed. This is the whole array R. It has 5 ints. That is 20 bytes. In the scope where you declared it, the compiler knows the full size. Look at the first element, R of 0. It sits at the start of the array. Its address is the address of the whole block. Now watch the array name decay to a pointer. All that is left is one cell. It holds the address 0x1000. The 5 values are gone from this view. The arrow shows the pointer still points to r of 0, the same memory, but the size is lost. Size of r is no longer 20. A plain pointer knows nothing about how long the array is. Decay happens in most expressions, but not every one. There are 3 exceptions. First, sizeof r. Here the array keeps its full size. It does not decay. Second, ampersand r. This gives a pointer to the whole array with a different type. Third, a string literal used to set up an array, like char name equals Alice. That fills the array. It does not decay. These exceptions explain why sizeof works on an array in the scope where you declared it, but not inside a function. Here sizeof tells arrays and pointers apart. Sizeof R returns 20. That is 5 int times 4 bytes, the whole array. Sizeof P returns 8, the size of a pointer on a 64-bit system. The array did not decay inside sizeof, so it reports the real size. The pointer only ever reports pointer size. This is why sizeof R divided by sizeof R of 0 counts elements, but only in the scope where the array was declared. Now the key equivalence. Bracket notation is not magic. The C standard defines R of I as star of R plus I. First, the name R decays to a pointer to the first element. Second, R plus I computes the address of element I, scaled by the size of one element. Third, star of R plus I reads the value at that address. So R of I and star of R plus I are two ways of writing the exact same thing. These are 5 ways to say the same thing. R of 2, star of R plus 2, P of 2, star of P plus 2, and the strange-looking 2 of R. All 5 print 30. The first 4 should feel natural by now. The last one, 2 of R, looks bizarre but is legal. Since R of 2 means star of R plus 2 and addition can be flipped, 2 of R is star of 2 plus R, the same value. Do not write 2 of R in real code, but it proves that brackets are just pointer arithmetic plus a dereference. Now the central mystery resolves. When you pass an array to a function, the name decays to a pointer. The function receives a pointer to the first element, not a copy of the array. Look at show sizes. In main, sizeof data is the full array. But inside the function, sizeof R is just pointer size because R is a pointer. That is why the caller also passes size as a separate parameter. The function has no other way to know how long the array is. Here we see the output. In main, sizeof data is 20, the full 5 times 4 bytes. Inside the function, sizeof R is 8, the size of a pointer on a 64-bit system. The array decayed when it was passed. So remember this. Inside a function, sizeof R gives pointer size, not array size. The array already decayed. Always pass the length as a separate parameter. This is why every array function you have written took a size argument. Now a surprise. The parameter declaration is a lie. When you write array brackets in a parameter, the compiler quietly turns it into a pointer. Void f of int r brackets means r is int star, not an array. Void f of int r of 5, the 5 is ignored, r is still int star. And void f of int star r is the same thing. All 3 declarations are identical. The compiler does not check that you pass exactly 5 elements. This book writes int star r in parameters to keep the truth visible. This is main. It owns the array called data. 5 values, 10, 20, 30, 40, 50. This is the real memory. Now we call print array with data. The array name decays to a pointer. The function receives only R. It holds the same address, 0x1000. The blue arrow shows R points to the very same memory as data. But something is lost. Inside the function, size of R is only 8 bytes, the size of a pointer. It is not 20. The array size is gone. That is why you always pass the length as a separate parameter. Arrays and pointers are related, but they are not the same. Sizeof gives the full array size, but only pointer size for a pointer. You cannot assign to an array name, but you can reassign a pointer. An array is the block of memory. A pointer only refers to a block. And in a function parameter, an array decays to a pointer, while a pointer is already a pointer. The most practical difference is that you cannot assign to an array name. This is that practical difference. You cannot assign to an array name. P equals BRR is fine. The pointer P now points at BRR, but R equals BRR is a compile error. You cannot assign to an array. An array name is a fixed label for one block of memory. It always refers to the same block. A pointer is a variable, so you can redirect it anywhere. If you want to copy the contents of one array into another, use memkey or write a loop. Let's look at a real example. Double elements takes a pointer and a size. It loops and sets r of I to r of I times 2. Because r is really a pointer into main's array, each write changes the original data. Before the array is 3, 7, 1, 9, 4. After it is 6, 14, 2, 18, 8. Remember, r of I is star of r plus I, so each write lands in the caller's array. There is no copy and no return value. The function modifies the array in place. This is the classic mistake, using sizeof to get the length inside a function. The code writes n equals sizeof r divided by sizeof r of 0, but r already decayed to a pointer. Sizeof r is 8, the pointer size. If an int is 4 bytes, n becomes 8 divided by 4, which is 2. The loop only processes the first 2 elements, no matter how big the array really is. The fix is simple. Pass the length as a separate parameter. Many compilers warn about this with -wall, so pay attention to that warning. Let's recap. Array decay is the one rule that ties arrays and pointers together. In most expressions, an array name decays to &r of 0, and the size is lost. Sizeof and &r are exceptions, where the array keeps its full identity. R of I is defined as star of r plus I, so brackets also work on pointers. Passing an array passes a copy of the pointer, which is why functions can change the original array. And always pass the length separately, because you cannot recover it from a decayed pointer. Next, sometimes you want to promise that a function will not modify the data it receives. You will learn how const works with pointers, the difference between a pointer to const data and a const pointer.